Hi, this is King of Review. Find the range for real number r if the following infinite geometric sequence is convergent. 1 r over 2, r squared over 4, r to the third power over 8, and this sequence continues. So we're dealing with a geometric sequence. A geometric sequence is a list of numbers or terms where the ratio of any term to the previous term is constant, so it has a common ratio. And we're told that this sequence is an infinite geometric sequence. These dots here show that it's an infinite geometric sequence. An infinite geometric series has infinitely many terms, yet it has a finite sum. And we're also given the bit of information that this sequence is convergent. What does this mean? A sequence converges if the sum equals a finite value, and a sequence diverges if the sum goes to either infinity or negative infinity. So we have some conditions for convergent versus divergent series. So convergent when a series is convergent, the absolute value of the common ratio must be less than 1. But if the series is divergent, the absolute value of the common ratio is greater than or equal to 1. Another way of writing the absolute value of r is less than 1 is negative 1 is less than r, and r is less than 1. We write it like this because if you take the absolute value of r is less than 1, you have r is less than 1, and r is greater than negative 1. And when you put these two together, you get this condition here. Negative 1 is less than r, and r is less than 1. So why is this? Let's take a look at the graph of a convergent series and the graph of a divergent series. Again, if it's convergent, then r must be between negative 1 and 1. So let's say that r is equal to 1/2. So this is r. We're going to say y is equal to 1/2 n. And here's our x-axis and our y-axis here. So I just want to plot y equals 1/2 to the nth power. And what happens here is if r is any number between negative 1 and 1, which it's 1/2 here, so it meets that condition, then r to the n power approaches 0 as n gets larger. So on the x-axis, I'm going to have n. So we'll plot when n equals 1, n equals 2, n equals 3, and n equals 4. And then over here for y, I'm going to have f of n. So when we plot these, I'm going to say that this here is 1/2. This is 1/4. This is 1/8. So when we plot this, if n equals 1, f of n, or the y coordinate, is going to be 1/2. When n equals 2, so 1/2 to the second power, this is going to be 1/4. And when n equals 3, or 1/2 to the third power, this equals 1/8. And this continues when n equals 4, f of n will be 1/16. So if you connect these, you can see that we're approaching 0. Now let's look at if we plot a divergent series. So in this case, the absolute value of r must be greater than or equal to 1. So let's say in this case that r is 2. So we're going to plot y equals 2 to the nth power. Again, we'll have the x and y axis. Our x-axis will be n. Okay, so when we plot this, y equals 2 to the nth power, when n is 1, we get a y value of 2. When n is 2, that's 2 squared, which is 4. When n is 3, we get 8. And when n is 4, we get 16. So when we connect these, you can see that it's approaching infinity. So for a convergent series, which is what we're dealing with here, r must be in between -1 and 1. So let's go ahead and figure out what r is in this particular series here. So we can calculate r as r equals any term over its previous term. So we can do a2 over a1. You can also choose another term. So if we were to choose a3 for the numerator, its previous term would be a2. So a2 over a1, this is equal to r over 2 divided by 1, which equals r over 2. So we have a common ratio of r over 2. Let's see what value we get here. a3 over a2. a3 is r squared over 4, and this is divided by r over 2. When you work this out, you get r over 2. So the common ratio is r over 2. Now remember, if we have a sequence that's convergent, then we will have a sum. But if it's divergent, there is no sum. And we were told that this is a convergent sequence here. So now let's enter in the information that we know. We know that r must be in between -1 and 1. And our r value we calculated. So we have -1 is less than r over 2, which is less than 1. Now we're solving for r. We want r by itself in the middle here. So we're going to multiply by 2 on all sides. And this gives us -2 is less than r, and r is less than 2. And this is our final answer here. So letter A is correct. Thanks for watching.